Hey guys, this is our slope review. So we're going to prep before we get into perpendicular and parallel lines. Let's do a quick review from Algebra 1 on slope. So the paper you should be looking at is this paper right here. Just follow along as we go through them. We're going to classify slopes together, and then we're going to identify what the slopes are using a graph and ordered pairs. All right, so on this slope review, let's look at these arrows here. These arrows are going to be representing how they would look on a graph. So if the arrow is pointing up at an incline in any form of an incline, what would that be? Well, if it's moving up, we always reading from left to right, that would be a positive slope here. If it's doing the complete opposite, reading from left to right, it's going down as if we were walking down a hill, and so that would be considered a negative slope. If it's a horizontal straight line, as if we were walking on the floor, it's still possible, it's just a slope of 0. So there would be no incline and no decline. And the last one, if it's pointing vertical straight up and down, that's as if we were trying to act like Spider-Man and walk up a wall. Well, unless we are Spider-Man, we can't do it. So this would be considered undefined. All right, next thing, let's go ahead and look at how to find the slope of a line when we have the graph. So we're going to visually look at this and determine what the slope is of this line using the graph here. All right, so the way we need to do this is let's go ahead and look at this. There's 2 points on the graph, and that's how we're going to determine the slope. We are moving in the vertical distance, and we are moving horizontally. So the first thing I want us to look at is what would that even be called? Well, for one, your slope is represented by an M. So anytime we see this M, that's going to represent our slope, okay? There's a formula to this when we're looking at a graph, and it would be rise over run, if you remember from Algebra 1. So rise over run. The rise represents the up and down motion, so moving along the y-axis. And then the run is horizontal, as if we were running on the ground, so that would represent your x-axis. So let's go ahead and look at this here. So we're going to start left to right. So the furthest left point is A, and we're going to count how many units up until we hit where our second point is. And the way you should do this is actually tally each unit on the graph. So I'll show you how to do that. So starting at the point A, we're going to go up. So 1, 2, 3, 4 units. We're going to stop where it hits point B. So that means that M equals 4. And then over the run, so how many units to the right would we have to move? So let's count those. 1, 2, 3, 4, 5. So our slope in this case would be 4/5. Do not convert this fraction into a decimal. All right, number 2, let's look at this one. We'll notice at this one that when we classify this, it would be a negative slope. So we're going to read this left to right as well. So starting with P and going to Q. And let's count the units until we can reach Q. 1, 2, 3. So 3. Now, the difference between this one and this one is we're moving down. And anytime we're moving down on the graph, that's a negative number. So instead of just writing it as a 3, we're writing it as a negative 3 because it's moving down on the graph and not up. And now let's determine what our run is. So we're moving from left to right all the way to Q. 1, 2, 3, 4, 5, 6. So negative 3 over 6. Now, since we're moving to the right, it would also be positive. So we have a negative over a positive, which makes this number a negative. And we will always simplify this. Both numbers are divisible by 3. So we're going to divide by 3. Negative 3 divided by 3 is negative 1 over 2. So our final slope on this one is negative 1 over 2. All right, the last one here that we're going to do together is example 3 under slope review. We'll notice that this is a straight line up and down. So this is a vertical line. And what we know about vertical lines, if you remember from how we classified them, is that all vertical lines are undefined. So we know that this would be undefined. However, I want you to actually calculate the numbers. So let's start at the bottom and move to the top. Let's count the units from point N to point M. 1, 2, 3, 4, 5, 6. So our rise is 6. So m equals 6. Now, is there a run? Do we move any direction from left to right? No, we don't. There are no units, so it would be 0.
Mr. Cote, I get in contact with Mr. White's office.
So anytime we have 0 in the denominator, our answer would be undefined. Because remember, we are not Spider-Man and cannot walk up a wall. All right, let's look at the second part to this. Given ordered pairs, how are we going to find our slope? So let's look at example 5. They give us 2 sets of ordered pairs. Now we have to remember that ordered pairs are always in the order x, comma, y. So they give us 2 points here, and we're going to use those 2 points in order to determine what our slope is. Now, instead of looking at a visual graph, we're just looking at the points. So instead of using rise over run and counting the units, we're actually going to look at m equals the change in y over the change in x. That delta, or that triangle, it's called a delta, and it means the change in. So the change in something is always used in subtraction. So we're finding the difference from one point to another point. So here, the change in y would be y2 minus y1, because that's how we find the difference. We subtract over our change in x's. What is the difference between the two x's that we're given? So let's go ahead and label these and look at them. So we're going to find the slope of line AB. We are given points A and points B, where we are always in x and y, and this is x and y. Now you can say that this is point 1 and this is point 2, or you can say that this is point 1 and this is point 2. Either way, it'll work as long as you keep them the same throughout. So let's go ahead and give this one a try. M equals, we're going to do y2 minus y1. So we're going to start with y2, which is negative 1, minus y1, which is minus 5. So that'll be our numerator for the change in y. And then for the run, or the change in x, we're going to look at both of our x points. So then 6 minus a negative 2. Anytime you are subtracting another negative like this, be sure to put that in parentheses so we don't lose that second negative. All right, so that's how it should be set up. And now we are going to solve it. So negative 1 minus 5 would be negative 6. When the signs are the same, you add and keep the sign. And then you are divided by or over 6 minus a negative 2. Well, 2 negatives equal a positive, so I'm going to change that to a positive. 6 plus 2 is 8. Now, we can't leave it as negative 6 over 8 because we can simplify that. They are both divisible by 2. So we would divide the numerator and the denominator by 2. Negative 6 divided by 2 is negative 3. And then 8 divided by 2 is 4. So our answer for the final slope of AB would be negative 3 over 4. Always leave this as a fraction. Do not convert it to a decimal. All right, let's try number 6 real quick. Number 6 is line GH. So we're going to look at our points G and H. I'm going to label them for you as well. And if you'd like to do that just to keep your points straight, you can. If not, and you're confident you know which points, then you can just go right ahead. All right, let's look at this. The slope of line GH, we're looking at y2, which was 7, minus negative 3, so put that in parentheses like we did on number 5, over our second x, which is negative 6, minus negative 11. And now we solve. So 2 negatives equal a positive, that is 10, over negative 6 plus 11, which would be 5. When the signs are different, you subtract and keep the sign of the bigger number. Well, we're subtracting these two, and the sign of the bigger number is a positive, so we're going to keep it as a positive. This can also be simplified, so be sure to simplify that. They are both divisible by 5, so 10 divided by 5 is 2, 5 divided by 5 is 1, and so we are left with slope is 2. All right, the 7th one and the last one that we're going to do together is going to be find the slope of line XY. So let's go ahead and look at these two points, X and Y. So this will be our X1 and our Y1, and this will be our X2 and our Y2. Let's go ahead and set that up for a slope. Change in Y over the change in X. So 2 minus a negative 4, same thing. Keep that in parentheses as your second negative, over 9 minus 9. So let's go ahead and get this solved. So 2 minus a negative is a positive. That is 6 over 9 minus 9, which is 0. Anytime 0 is in the denominator, that is undefined. So our answer would be undefined. All right, so go ahead and finish up slope. Your assignment for this will be this page here. It's just the homework document. You're gonna do numbers 1 through 12, numbers 1 through 12. Thank you guys, good luck.